Hi Hrishikesh.
Yes, Sriram. I did not know how to do the program on prime numbers. Can you help me with that?
Yeah, sure. It's my pleasure. Before this, let me know how comfortable you are with the concept of loops. Because having a good grip on concept of loops is essential to understand this program better.
I'm not very much confident on loops.
Okay, how about using arithmetic operations as part of programming?
I am comfortable with using the basic operators, but not with the mod operators.
Okay, I see. I trust you're comfortable with the concept of program structure then, taking input and displaying the output.
Yeah, I'm pretty much clear on that.
Good. Now let us use this understanding to understand the concept of operators better. And with that incremental knowledge, let us know the concept of looping better. This foundation surely helps us to understand the program you have mentioned earlier.
Thank you very much. I think you're following a recursive approach to address my problem here, right?
Yes, perfect. Breaking a more significant problem into numerous subproblems and combining the solutions of all the subproblems is a characteristic of recursion.
However, the base case must be there. Thank God I could say yes to your last question. Otherwise, our discussion would have gone into an endless loop.
Yes, you pointed it well. If there is no terminating condition, recursion goes endless.
Great. So let's get on with the program structure and operators then.
Thanks to Hrishikesh and Sriram for introducing us to the concept of recursion in day-to-day life. Let us now explore simple program executed using recursion. Our task is to find sum of n numbers. Here we are taking n as 5. Instead of adding 1 to 5 numbers iteratively, let me get sum of 4 numbers and add 5 to it. How can I get sum of 4 numbers? Get sum of 3 numbers and add 4 to it. Like this, in recursive way, we can continue up to sum of 1. Sum of 1 gives us the value 1. Use this value to get sum of 2. That is 2 plus 1 is equal to 3. Apply value 3 to get sum of 3 numbers as 6. Value 6 is used to get sum of 4 numbers, which is 10. Added 5 to sum of 4 numbers to get 15 as the final result. Now let us see flow of the program and how the function sum is called recursively. In main program, we are reading the value n and sending it as an argument to the function sum. In function sum, we are checking if value of n is equal to 1. If so, we are returning 1, else we are returning n plus sum of n minus 1. This recursive call gets repeated until n is equal to 1. We can understand that there are 3 essential elements to apply recursion: base case or terminating condition. In our example, the terminating condition is n equal to 1. And also feasibility to break each problem into subproblems and combining solution of subproblems to arrive at the final result. These are the 3 critical elements to apply recursion. This slide gives complete picture on how recursive program looks. If we know the base case, recursive statement, which divides problem into subproblems, recursion program is very easy to implement. We can see more examples where we can apply recursion. To find GCD of 2 numbers, we can use recursion. GCD of A comma B is equal to GCD of B comma A mod B. Let us take example of 10 and 6. GCD of 10 comma 6 is GCD of 6 comma 4 because 10 mod 6 is 4. Similarly, GCD of 6 comma 4 can be reduced to GCD of 4 comma 2, and this again is equivalent to GCD of 2 comma 0 because 4 mod 2 is equal to 0. Here we are meeting the base condition. The second number becomes 0. Hence, you have to return the first number as GCD of two numbers, and here in our case, GCD of 10, 6 is 2. Similarly, we can apply recursion for finding factorial and also nth element of Fibonacci series. There are many other examples which we'll be seeing in coming up classes.